In the center of the ancient Roman town of Baia, there is a temple. It was built at sea level. It is magnificent. Marble columns, vaulted ceilings, the architectural ambition of an empire at its peak. And it is currently 20 feet underwater, sitting on the floor of the Bay of Naples. Not because the sea rose, because the ground beneath it sank. And then the ground rose again, and then it sank again. The temple has been doing this for 2,000 years, en renoir, moving up and down with the breathing of something enormous, buried beneath the Italian coastline. Something that the ancient Romans called Phlegrean Fields, the burning fields. We call it Campi Flegrei. And right now, for the first time in recorded history, scientists using artificial intelligence have seen inside it clearly enough to read what it is building toward. Since 2005, the ground across the caldera has risen by more than 6 meters. Seismic activity is increasing together with ground deformation, both accelerating simultaneously. The current data points toward a period between 2030 and 2035 when the system is expected to reach a critical state, with the strongest estimate focused on 2033. The watchers, 7 years, and the city sitting on top of all of it is Naples. Population, 900,000. Metropolitan area, 3 million people. The most densely populated volcanic zone on the surface of the Earth. Stay with me, because the 2033 timeline is the most alarming number in this script, and it is also the most contested, the most uncertain, and the most misrepresented in all coverage of this volcano. I am going to give you the honest version, the version that the scientists are actually debating, the version that contains something more alarming than the eruption scenario. Because the single thing that Bill Ellsworth, the Stanford professor who co-directs the Center for Induced and Triggered Seismicity, said should concern us most about Campi Flegrei right now is not a volcanic eruption. He said, one of the biggest concerns in the short term in Campi Flegrei is not an eruption, but a moderate earthquake at shallow depth. Wildfire Explorer. A moderate earthquake under a city of 900,000 people, with buildings that were not built to withstand what is coming. We are going to explain exactly why. Stay with me. First, the geography. Because this is not the volcano you're picturing. Campi Flegrei is an 8-mile-wide caldera, a massive depression formed by major volcanic eruptions about 39,000 and 15,000 years ago. Wildfire Explorer. Not a cone, not a mountain, a caldera. The collapsed shell of a volcano so large that when it erupted 39,000 years ago, it was the biggest volcanic event in Europe in the last million years. The eruption covered most of Europe in ash. Geologists found its deposits in ice cores drilled in Greenland, in cave sediments in the Ural Mountains, in the Black Sea floor. Around 37,000 years ago, Campi Flegrei erupted with a volcanic explosivity index of 7, an event far more powerful than the eruption of Mount Vesuvius in 79 AD that buried Pompeii. The eruption created a massive caldera, roughly 12 kilometers wide. CBS News. The crater that eruption left behind is where Naples' western suburbs are built today. The towns of Pozzuoli, Bagnoli, and Quarto sit directly inside it. The neighborhoods of western Naples extend to its eastern rim. And since 2005, that crater floor has been rising. The ground has risen more than 6 meters since 2005. This uplift is not uniform. It is concentrated in a pattern that is now, for the first time, visible in extraordinary detail thanks to artificial intelligence applied to 2 decades of seismic data. The watchers. The ground beneath Pozzuoli, a town of 80,000 people directly above the center of the uplift, has risen 1.5 meters in 19 years. That is the height of a doorknob from the floor, raised by pressure from below, from something pushing upward against 12 kilometers of rock, 80,000 people, and several thousand years of Italian history built on top of it. Here's the discovery that changed everything scientists thought they knew about this volcano. Researchers at Stanford University, Italy's National Institute of Geophysics and Volcanology, and the University of Naples applied a retrained machine learning model to seismic data recorded at Campi Flegrei from January 2022 to March 2025. The analysis expanded the seismicity catalog from around 12,000 to more than 54,000 earthquakes. The AI detected 4 times more seismic events than the standard monitoring network had recorded. Wildfire Explorer, 54,000 earthquakes in 3 years, most of them too small for standard instruments to detect individually. But together, mapped, located, and analyzed, they revealed something that stunned the Italian scientists who had been watching this volcano for decades. Previously, the structure of seismicity in the caldera was indistinct, and now we've seen a very thin and well-marked ring fault that is consistent with the surface features, said Professor Greg Barroza of Stanford, who supervised the research. Wildfire Explorer, a ring fault, clearly visible for the first time. Clearly, tracing the exact circular boundary of the caldera, including, critically, in the northern section of the caldera that runs beneath the densely populated neighborhoods, where scientists had never seen it clearly before. Our Italian colleagues were surprised to see the ring so clearly, said lead author Xing Tan, a geophysics PhD student. They expected to see something in the south, where previous data had revealed scattered seismicity, but in the north, they'd never seen it so clearly. Wildfire Explorer. The northern part of the ring fault sits directly beneath urban Naples, and then came the sentence from Bill Ellsworth that defines this discovery's real-world consequence. These long faults suggest that an earthquake in the magnitude 5 range is not out of the question, Ellsworth said. We've known that this is a risky place for a long time, since the 80s when part of the city was evacuated, and now we're seeing for the first time the geologic structures that are responsible. Wildfire Explorer Magnitude 5. On a ring fault beneath a city where tens of thousands of buildings were constructed before modern earthquake codes existed, where the narrow streets of the historic center would trap residents attempting to evacuate, where the infrastructure of a major European metropolitan area sits directly above the fault plane that the AI just made visible. Here is the detail that should stop you cold. The strongest earthquake in the current cycle of Campi Flegrei unrest struck on June 30th, 2025. A magnitude 4. 6 earthquake was registered, the largest recorded in the Campi Flegrei region since the current cycle of seismicity began. Georgia Forestry Commission M4. 6. The largest in the current cycle. And it was felt across Naples. People ran into the streets, windows cracked, ornamental plasterwork fell from historic facades. In the older neighborhoods of Pozzuoli, where buildings have been weakened by decades of ground uplift and previous earthquake swarms, structural damage was reported. M4, 6 was the largest. And the Stanford team says M5 is not out of the question. The difference between M4, 6, and M5. 0 is not 10% more energy. In earthquake physics, each whole number on the magnitude scale represents approximately 32 times more energy released. M5. 0 is roughly 8 times more powerful than M4. 6. In 1982 to 1984, the previous major unrest crisis at Campi Flegrei produced more than 1,300 monthly seismic events, with ground uplift as high as 9 centimeters per month. In 1984, the Italian government evacuated 40,000 residents of Pozzuoli. They relocated them to new housing on the mainland. The ground was shaking too frequently and too strongly for the old town to be considered safe. That decision, relocating 40,000 people from one neighborhood of the affected zone, was the largest peacetime volcanic evacuation in European history. And it did not require an eruption. It required an earthquake swarm. The same thing happening right now at accelerating rates on a ring fault that the AI just revealed extends beneath a much larger area than the 1984 crisis affected. Here is what the German scientists at GFZ Potsdam found inside the data, and why it matters. An international team from the University of Pisa, Italy's INGV, and the GFZ Helmholtz Center for Geosciences published findings in Nature Communications, Earth and Environment, analyzing volcanotectonic earthquakes at Campi Flegrei over the past 10 years. They discovered long-period seismic signals indicating a fissure-like structure at a depth of approximately 5 kilometers. Georgia Forestry Commission, 5 kilometers. A fissure, not a point source of magma, not a single pressurized chamber. A crack-like structure filled with fluid, likely a mixture of magmatic gas and superheated water, sitting 5 kilometers beneath the populated surface of the caldera. In June 2024, GFZ, in cooperation with Italy's Osservatorio Vesuviano, installed 9 new seismometers in the Campi Flegrei to strengthen the local network. Since then, these have been sending data to GeoFon in real time and contributed to the current study. Georgia Forestry Commission, 9 new instruments, installed in 2024, because the existing network was not adequate for the level of activity being recorded. This is the monitoring infrastructure story of Campi Flegrei. Every time scientists get a clearer picture of what is happening beneath the caldera, the picture reveals something more complex, more extensive, and more structurally significant than the previous generation of instruments could show. The AI revealed 54,000 earthquakes, where 12,000 were known. The new seismometers revealed a fissure that previous data had only suggested. The science is getting more precise at exactly the moment the system is getting more active. Here is what is not making headlines. The weekly INGV monitoring bulletins, published in Italian, read by volcanologists, largely invisible to English language media, contain a specific measurement that tells you exactly how the uplift rate has been changing in real time. Following the seismic swarm of February 15, 2025, data showed an increase in the rate of ground uplift, with an average monthly value of about 30 millimeters per month until the end of March. From April 2025, ground uplift continued at about 15 millimeters per month. Starting from October 10, 2025, an increase in the ground uplift rate was recorded. with an average monthly uplift value of about 25 millimeters per month. Since mid-December 2025, a decrease to about 10 millimeters per month has been recorded. CBS News. The uplift rate is not constant. It pulses. It accelerates after swarms, then moderates, then accelerates again. Each pulse corresponds to a new injection of fluid, magmatic gas, superheated water, or a combination, into the hydrothermal system that sits between the magma reservoir and the surface. The total effect of those pulses, accumulated since 2005, is 6 meters of ground rise in 19 years, in a city that sits on top of the caldera. And those 6 meters are not evenly distributed. They are concentrated at the center of the caldera, directly beneath Pozzuoli, tapering toward the edges, which means the ground has tilted. Roads that were flat in 2005 now have a measurable slope. Buildings that were plumb in 2005 now lean. Foundations that were designed for stable ground are now sitting on ground that has been deformed by nearly 2 meters of vertical movement. The buildings of Pozzuoli were not engineered for 6 meters of ground uplift. They were not engineered for M4, 6 earthquake. They were not engineered for the M5, 0 that the Stanford team says is not out of the question. And there are tens of thousands of them. Here is the historical parallel that makes the 2033 timeline alarming rather than simply academic. The last time Campi Flegrei erupted was 1538 AD, 488 years ago. A vent opened in the western part of the caldera, and in a matter of weeks, a new mountain, Monte Nuovo, New Mountain, grew out of what had been flat ground. The eruption destroyed the town of Tripurgol, which ceased to exist. An eyewitness account describes the ground cracking, a roar, and then fire erupting from the earth in a location where there had been no volcano the previous morning. Before that eruption, the ground had been rising for years. The harbor at Pozzuoli had become too shallow for ships to dock because the seafloor had risen. Earthquakes were occurring daily. Springs that had been cold turned hot. The ancient Romans had noted a similar pattern during periods of unrest that did not produce eruptions, and periods of unrest that did. A new study by Zaccagnino, Sornet, Iaccarino, and Picozzi, published in 2026, identifies a clear trajectory in the current acceleration of both deformation and seismic activity at Campi Flegrei. Instead of stabilizing or slowing, both metrics are increasing together. This type of behavior is associated with systems where internal pressure is building faster over time, driven by feedback processes beneath the surface. The current data points toward a period between 2030 and 2035, when the system is expected to reach a critical state. WGCU critical state. That is the scientific term. Not eruption, not necessarily. A critical state means the system has reached a threshold beyond which the current behavior cannot continue without some kind of release. That release could be a large earthquake. It could be a hydrothermal explosion. It could be the opening of a new vent. It could be an eruption. Or it could be none of these. Volcanic systems are not predictable clocks. And the current unrest could stabilize and reverse. But the trajectory is documented. The acceleration is measured. And the direction of travel, upward, louder, faster, has been consistent for 19 years. Now, pull back to the question that the Italian government is actually grappling with. If the decision is made to evacuate, not Pozzuoli's 80,000 residents, but the full zone of risk around Campi Flegrei, how many people are moving? More than 1 million people live within or along the margins of Campi Flegrei. Urban infrastructure, transport networks, and essential services are all located directly above the zone where these changes are taking place. WGCU, 1 million inside the direct margins. Naples proper, 900,000 more. The metropolitan area, over 3 million. There is one road out of Pozzuoli that does not pass through Naples. The A56 motorway runs along the northern edge of the caldera, in an earthquake scenario severe enough to disrupt road surfaces, which the current monitoring data suggests is possible from an M5. 0 event on the ring fault. That route could be compromised before evacuation is complete. The Italian Civil Protection Department operates a graduated alert system for Campi Flegrei with 4 levels: green, yellow, orange, and red. The current level is yellow, the second lowest. It has been at yellow since 2012. Yellow means conduct normal activities, increase monitoring, prepare plans, review evacuation procedures. The caldera has been at yellow for 14 years. 14 years of prepare plans, 14 years of review evacuation procedures. While the ground rose, 6 meters. While 5 M4 plus earthquakes struck in 2025 alone. While AI revealed 54,000 earthquakes nobody had counted, and a ring fault nobody had seen clearly. The Italian government's official Campi Flegrei evacuation plan, Piano Nazionale Emergenza, Campi Flegrei, covers approximately 500,000 people in the highest risk red zone. It calls for their evacuation to partner regions across Italy in the event of an escalation to the red alert level. The plan was approved. The partner regions were designated, the logistics were mapped. The last formal exercise of that plan involved moving a sample of residents through the process. It took significantly longer than the plan assumed. The roads into and out of the caldera during a simulated daytime emergency did not flow at the speeds the evacuation timeline required. An earthquake at M5, 0 on the ring fault beneath northern Naples, does not wait for the evacuation to begin. So ask yourself 3 questions. An AI analysis expanded Campi Flegrei's earthquake catalog from 12,000 to 54,000 events and revealed for the first time a clearly defined ring fault extending beneath the northern urban area of Naples. Bill Ellsworth of Stanford stated that a magnitude 5 earthquake is not out of the question on these newly identified faults. The largest earthquake in the current unrest cycle was M4, 6 in June 2025. Naples contains tens of thousands of buildings constructed before modern earthquake engineering standards were implemented. The Italian government's evacuation plan covers 500,000 people in the red zone. If the most likely near-term dangerous event at Campi Flegrei is not a volcanic eruption, but a moderate earthquake at shallow depth, as the leading scientists on this system have stated on record, why is the public communication framework around this volcano built entirely around volcanic eruption scenarios? And who is responsible for communicating the earthquake risk to the 900,000 residents of Naples whose buildings sit on the ring fault that the AI just made visible? Wildfire Explorer. Ground uplift at Campi Flegrei has been ongoing since 2005, totaling 16 meters. The rate pulses, accelerating to 30 millimeters per month after major swarms, moderating, then re-accelerating. The system has been at Italy's yellow alert level since 2012, 14 consecutive years at the second lowest alert designation. Yellow means prepare, review, plan, not evacuate, not escalate. In those 14 years, the ground rose 1. 6 meters, the strongest earthquake in the cycle struck. 5 M4 plus earthquakes occurred in a single year. A new fissure structure was discovered at 3. 5 kilometers depth, and a ring fault was revealed beneath populated urban areas. What is the specific threshold, the specific measurement, the specific event, the specific combination of indicators that moves Italy's civil protection from yellow to orange? And has that threshold been publicly communicated to the 3 million people who live within range of Campi Flegrei? CBS News. And if the 2026 study by Zaccagnino et al. Identifies 2033 as the year the system is expected to reach a critical state based on the current trajectory of accelerating deformation and seismicity, and the evacuation exercise revealed that moving even a portion of the at-risk population takes longer than the plan assumed, and the ring fault now visible beneath northern Naples runs through urban areas that were not included in the highest risk red zone designation that the evacuation plan is built around. Who updates the red zone? When is that update communicated to the residents? And what does a resident of Pozzuoli do with a 7-year timeline that a government has acknowledged exists, but a yellow alert level has not yet translated into mandatory action? WGCU. Right now, as you read this, the ground beneath Pozzuoli, Italy, is 6 meters higher than it was in 2005. It is being pushed upward by something at 3. 5 kilometers depth, a fissure-like structure filled with pressurized fluid that GFZ scientists published in Nature Communications. By magmatic gas, migrating upward through fractured rock, that INGV's monitoring network has been tracking for 2 decades, by a system that has now been measured by 54,000 earthquakes that nobody had counted before the AI looked at the data. The AI research suggests overall inflation of the caldera is driving earthquake activity through pressure. The study authors did not observe any direct signature of upward migration of magma. Wildfire Explorer, no magma migration detected, not yet. The distinction between the hydrothermal system and the magmatic system, between pressurized water and pressurized molten rock, is the difference between a very dangerous situation and a potentially catastrophic one. But the Stanford team noted that the absence of detected magma migration does not mean the system is stable. It means the instruments in place could not find it before the AI, before the GFZ seismometers, before the 54,000 earthquakes that were invisible until someone looked harder. In Pozzuoli tonight, the Solfatara crater, the thermal feature at the center of the Campi Flegrei caldera, where sulfurous gas vents from the earth in white plumes, where tourists walk paths around fumaroles that reach 160 degrees Celsius, is open. It was closed for years after a family fell into a thermal vent in 2017 and died. It reopened. Tourists are walking it tonight, standing beside gas vents, photographing sulfur deposits, watching the ground steam. 2 kilometers below their feet, a fissure-like structure is pressurized. 4 kilometers further down, a magma reservoir sits beneath the caldera that 2 of the largest eruptions in European history emptied. The last time that reservoir moved enough to produce an eruption, a new mountain grew out of flat ground in a matter of weeks, and a town was erased. That was 488 years ago. The current data points toward 2033 as when the system is expected to reach a critical state. The ground continues to rise, earthquakes continue to occur at increasing rates. Gas continues to move upward through the crust. WGCU, 7 years. The Roman temple at Baia has been rising and falling for 2,000 years, and no one who built it could have predicted what was underneath it. The people who built Naples could not have predicted it either. The AI can see it now. And the question it cannot answer, the question that has no instrument, no algorithm, no model precise enough to resolve, is what 2033 looks like for 3 million people living above the burning fields.